The U.S. Space Agency NASA has selected 3 design concepts for a nuclear fission surface power system that could be launched by the end of the decade for lunar demonstration. In order to receive the finance and development, it needs to advance sufficiently to support our decarbonization efforts. Nuclear fission may need to go over a public perception barrier on Earth, but the relatively vacant lunar surface gets around a lot of nuclear image problems.
Welcome to another video of Cosmos Observer, the only destination for your space curiosities.
The concept designs for nuclear fission energy systems intended for use on the moon will be provided by 3 providers. 3 of the top concepts have now been chosen by NASA and the Department of Energy authorities. In a competition run by the Idaho National Laboratory, projects run by the Aerospace and Energy Corporation's Lockheed Martin, Westinghouse of Cranberry Township, and IX, a partnership between Intuitive Machines and X-Energy, have each been given $5 million over a 12-month period to construct prototype designs for the future power source. The American Space Agency's most ambitious human spaceflight mission to date, Artemis, will depend heavily on its power plants. The goal of this massive mission is to land the first woman and first person of color on the moon and establish a sustained presence there. NASA envisions astronauts residing in a lunar base camp, traveling the surface in rovers, and using the moon as a launch pad to continue their solar system exploration. It'll need to find a way to produce a sufficient amount of power for this to occur. The mainly vacant lunar surface avoids much of the nuclear image problem, but nuclear fission may need to surpass a public perception barrier here on Earth. Fission surface power is now in play. The energy generated when atoms like uranium split apart is captured by a nuclear fission reactor. Contrary to solar panels, fission reactors can produce power continuously and can be positioned in areas of the lunar surface that are chilly and gloomy and receive little to no sunshine. For the first lunar settlers, NASA estimates that 40 kilowatts of power will be required. The agency and the U.S. Department of Energy solicited businesses to submit concepts for how to construct such a system last year. One of the needs for this project, which is being worked on by the Department of Energy and NASA, is a 40 kilowatt power generation capability that can persist for at least 10 years. The Nissan Leaf would surely continuously generate that energy as it's a fission generator, but for the entry-level model, that is roughly how much energy is stored in a full charge. According to a press statement from NASA, these contracts for $5 million will help develop the basic ideas for a 40 kilowatt class fission power system. And according to Idaho National Laboratory Director John Wagner, the fission surface power project is a very doable first step toward the United States generating nuclear power on the moon. NASA believes that fission power systems ensure constant power regardless of environmental factors including location, sunlight, and other natural circumstances by being considerably smaller and lighter than conventional power systems. The space agency would benefit from these systems when it conducted extended trips to the moon and Mars. Nuclear propulsion technologies that rely on reactors to generate power will also be developed with their assistance. New technology propels our exploration of the moon, Mars, and beyond, said Jimmy Reuter, Associate Administrator for NASA's Space Technology Mission Directorate. By building these types of prototypes, we can lay the groundwork for long-term human habitation on distant worlds. NASA and the Department of Energy work together on this. NASA's deep space exploration missions are reportedly made possible by the fission power system. NASA will receive crucial industry data from the Phase 1 awards, which can help with the cooperative development of a fully flight-certified fission power system. NASA's development of nuclear propulsion systems that rely on reactors for electricity will also be aided by fission surface power technology. Missions to explore outer space may make use of these systems. The conditions on the moon and Mars, for that matter, amplify many of the difficulties we experience with alternative power sources, including solar here on Earth. In particular, they must be able to function reliably in adverse conditions and without access to sunlight. The work completed under this contract, according to NASA, may also be used in the future to develop propulsion systems for long-range spacecraft used for deep space exploration. Since the ones from the current generation are in the 100 watts range, this is a 400-fold improvement. However, they will have enough mass and volume to do that. Trying to come up with additional reactor alternatives. Theoretically, a pressurized reactor of some sort would be feasible, but the design would be difficult due to the significant difference in temperature between day and night. The NASA Glenn Research Center in Cleveland oversees the agency's fission surface power projects. The Marshall Space Flight Center in Huntsville, Alabama, hosts the Technology Demonstration Missions program, which provides funding for the power system development. The primary goal of the contract's first phase is to give NASA further details on how to construct a complete flight-certified fission power system that could be launched to the moon for testing and safety by 2030. The final design must be able to generate electricity for 10 years. Other programs that will aid future astronauts in surviving more than 200,000 miles from Earth are also funded by NASA. Humans will require food and a way to contact those back home. Providing NASA with further information on how to build a full-flight certified fission power system that could be sent to the moon for testing and safety by 2030 is the main objective of the contract's first phase. For 10 years, the finished design must be able to produce electricity. NASA also funds other initiatives that will let future astronauts survive more than 200,000 miles from Earth. Food and a way to communicate with those back at home are necessities for humans. For the first time, researchers at the University of Florida were able to cultivate microscopic Arabidopsis thaliana plants in lunar soil, which are edible weeds related to mustard greens and other vegetables like broccoli, cauliflower, and Brussels sprouts. During the Apollo 11, 12, and 17 flights, the dirt was gathered. However, compared to plants growing in Earth soil, they were weaker and smaller. As part of the Prime 1 mission, which is scheduled to launch next year, NASA is also launching 2 instruments to dig and examine ice cores beneath the lunar surface in search of water. Nokia has been allocated $14.1 million and given the assignment of constructing a 4G moon communications network. The system should be designed to handle enough bandwidth that the future space explorers should be able to communicate data, drive lunar rovers remotely, and broadcast videos in high definition. Topics prioritized in this early phase of exploration planning are not intended to dictate design features beyond the interfaces. The standards include avionics, communication, environmental control and life support systems, power, rendezvous, robotics, thermal control, and software. Current space station partners will provide important contributions to Gateway, comprising advanced external robotics, additional habitation, and possibly other enhancements. Canada announced in February 2019 that it intends to participate in the Gateway and contribute advanced external robotics. In October 2019, Japan announced plans to join the United States on the Gateway with contributions of habitation components and logistics resupply. In November 2019, ESA received authorization and funding to support its planned contributions to the Gateway, including habitation and refueling. Russia has also expressed interest in cooperating on the Gateway. Long-term moon exploration and development depend on mobility. The moon's topography is complicated, and its resources are spread in addition to its vastness. The vast scope of the lunar geography is reflected in the evaluation of potential locations for the Artemis base camp, such as those close to Shackleton Crater. Robust mobility systems will be required to investigate, develop, and use in Mars and the Moon. The mobility platform is an especially useful crucial component of the mission, as the first Mars expedition will use a comparable spacecraft. All key elements necessary for a successful human return to the Moon are in development, with American commercial lunar robotic missions setting the pace in 2021. Deep space transit systems for NASA are currently undergoing their final testing before integration. The flight of Artemis 1 and Artemis 2 tests will confirm the performance of rockets and spacecraft and put America on track to once more astronauts to the Moon once more. Additionally, NASA will collaborate with industry players to develop landers and carry out risk reduction tests before the landings on the Artemis 3 mission and thereafter. NASA will leverage years of hard work and national investment in the systems needed to return to the Moon, while enabling current and new partners and capabilities to achieve sustainability, all of which will lead to the first human mission to Mars. This vision, coupled with support from key stakeholders and one of the strongest budgets in NASA's history, is the way forward to the Moon. With modern deep space systems in development, a growing corps of astronauts, and new science investigations and technologies planned to study the Moon ahead of a human return, we are closer to landing a crew on the Moon again than at any other time in our history since the Apollo program. The sooner we go to the Moon, the sooner we send astronauts to Mars.